Hello, Year 8. Sorry we can't have a live lesson today, but I'm in school, teaching in school, so I'm not actually available this lesson. So instead I've recorded you a little lesson for you to do at home. Now, so far in this topic on forces, what we've done is we have explored the types of force. We have explored force diagrams, we've looked at balanced forces, we've looked at unbalanced forces, we've looked at resultant forces, we've explored gravity, we've explored mass, and we've explored weight. Now, what we are going to do then today is we're going to start using what we've learned so far and apply that to a little bit of practical work. And the practical work that we are going to be doing over the next two lessons is we are going to explore the effect of forces on springs. And the whole purpose, the aim of the investigation that we are going to be doing is, do springs follow rules? Is there a rule that will explain how far a spring stretches? Now, you are going to need to have open for today's bit of practical work that link to that website that should be, I should have posted you on Edmodo to this website called Hooke's Law. This is going to be your virtual laboratory for today's bit of practical work. You're also going to need to have open this document, and on here what I've done is I've started a write-up for you. Okay, so here we've got investigating springs. Here we've got an aim to find out if there is a rule that can explain how far a spring stretches when a force is applied to it. Now, you can either write this up by hand on a piece of paper, or you can print this document off and fill in all your findings on this piece of paper. I've also should have attached it as a Word document. You can type directly into the Word document, excuse me, if you so wish as well. Whatever you choose to do, the only thing I ask is that you keep hold of it, please. Don't lose it, because this is going to need to go into your exercise book when we eventually return to school. Okay, so here's our aim: to find out if there is a rule that can explain how far a spring stretches when a force is applied to it. There's also then a space for you to fill in a prediction. So what I'd like you to do before you start the practical work is to write a prediction. What do you think is going to happen to that spring when you apply force to it? Now, obviously it's going to stretch. You apply a force to a spring, it's going to stretch. Okay, or compressed, depending on how you add that force. But we're going to be investigating stretching. But I want you to take that a little bit further. Is there a rule? Is that spring going to follow a rule whenever you apply force to it? Okay, so we've got a space there for a prediction. You will also notice that I've also written out for you a results table, and in this results table down here in the first column we've got force. Okay, that's going to be the amount of force that you apply to that spring. We've also got this second column that says stretch, and the units is meters. We've also then got the second column here where it says stretch in centimeters. Now, you will notice I have already filled in one result for you, and that is when the force on that spring is 0. Obviously, if you're not applying any force to that spring, it's not stretching at all, so the stretch is 0. Okay, now let's go back to the website that I want you to use. When you follow that link that I've sent you on Edmodo, this is where it will take you. You've got 3 options, one called intro, one called systems, one called energy. The one that I want you to use, please, is the one that says intro. And when you open that up, this is what you've got. This is your virtual laboratory. Here we've got a spring, okay, that's fixed at one end. Here we've got this thing. I don't know what this is supposed to be. Anyway, but this is what we're going to use to apply force to our spring. Up here, we've got several different options for you to choose. Now, I would like you, please, to switch all these on. So switch on applied force, spring force, something called displacement, something called equilibrium position, something called values. Okay. Bear with me a minute. I'm going to go back to how it would look for when you turn it on. Here you've got an option of 1 spring or 2 springs. Can I please ask that you choose one spring. Okay, now when you first open up your website, this is what it will look like. On this side here, we've got a thing that says applied force, and what this will allow you to do, this will allow you to apply force to that spring. Now you can apply positive force and you can apply a compressing force. We're not going to worry about this compressing force here where you've got negative values. We're just going to be dealing with the positive values. Over here you've got something called spring constant. Okay, when you turn it on, it should be set, I think, to 200. Can you please leave it set to a spring constant of 200? And the units there are newtons per meter. Now, if we go back to our write-up, sheet, you'll notice that the first test that I would like you to do is you are going to apply 1 Newton to your spring. So let's go back to our experiment. Here we are. I'm going to apply 1 Newton to the spring. Okay. And you'll notice here, look, that there's been a little bit of a change. And it says here 0.005 meters. So I go back to my results table. Okay, and I fill in here that the stretch was 0.005 meters. I would also like you, please, to convert that into centimeters, because that's going to make our life a little bit easier later on next lesson. So obviously 0.005 meters is the same as 0.5 centimeters. Okay, so each time just convert the meters into centimeters, because it will just make your life a little bit easier. Okay, we've then got 2 newtons. So we go back, we apply 2 newtons to our spring. Here's our stretch. Okay, this value here, that's how far it has stretched. On this, they're calling it displacement. Okay, what that means is how far it's moved from its what we call equilibrium position, which was where the spring was when there was 0 newtons on it. But what I want you to do, please, this lesson is you go through and you test all these different values, filling in the stretch in meters and then converting it into centimeters afterwards, please, as well. So little summary then. Okay, today you are investigating springs, and what you are doing is you are investigating whether springs follow rules, and if they do, what is that rule? Okay, you've got that write-up sheet that I've attached to the Edmodo post. Please make sure you do a prediction first. Okay, so write your prediction, then use that website to investigate how far a spring stretches when you add force to it. Keep your results safe, because you're going to be using those next lesson to write a conclusion for this little bit of work. I'm hoping that we can do that one live. Okay. As ever, have fun with it, and I will see you again soon.